This video will help you to solve and find feasible regions and minimize and maximize. Of course, this relates to linear programming. I've got a problem here that says they want me to minimize based upon z is equaling 27x plus 13y, and that of course is my objective function, and it's subject to these constraints. Now the first thing I have to do is go into my apps, and I'm going to cursor down to Inequalities. If you want to cursor down, you could also go alpha and I will take me to the I list. If not, again, cursoring down their alphabetical order to Inequalities. I'm going to hit enter, and this is going to start the app, and I'm going to clear out what I have. Now, this app is different than what you've seen on your regular grapher. Now it looks almost like my regular grapher, but where the equal sign is, when I cursor over to the equal sign and I'm there, I now have soft keys above each of these functions of my calculator. And I have equals, less than, equal to, greater, greater than, equal to. And as long as I'm on this equal sign, I can then have that soft key menu show. Well, of course, here I have my inequalities. The first thing I always have to do is solve for y. So the first one I've already solved for y, and I have y is greater than or equal to negative 7/5 x plus 7. So I need greater than or equal to. I have to be on that equal sign, alpha, and graph, because graph is the key right underneath that one. I'm going to cursor off, and as soon as I cursor off, it then goes back to not having those soft keys available to me, and I can input my inequality, which of course is negative 7/5 x plus 7. I'm going to cursor down now to y2 because I have a second inequality I need to put in. Again, I've solved that inequality for y. I have to cursor onto the equal sign to make those soft keys available. Again, I want greater than or equal to, greater than or equal to, so I'd say alpha and graph. Had I want less than, it would be alpha and zoom. I have to cursor off my operation of equal or greater than or etc. And I'm going to input my inequality as being negative 1/2 x plus 4. I'll then cursor down to y3. I'm going to cursor back onto the equal sign because I still have this x equals 0, greater than or equal to 0, we'll come back to in a moment, but I still have this y is greater than or equal to 0. So onto my equal sign, alpha greater than or equal to, cursor off, and I'm going to place a 0. Now I think the coolest thing of this app is the fact that I can now put in x equals line, and I can graph vertical lines. To do that, I need to access that screen. So I'm going to use my up cursor key, and I'm going to cursor all the way up to the x equals. I'm going to enter. Well, now I have my x equals, and since I'm on my equals, I have all of my soft keys available to me. I want x is greater than or equal to 0, so I'll put alpha greater than or equal to, cursor off that, and put a 0. Now, when you're graphing these feasible regions, you want to make sure that you get your window set. Well, first off, we know by the fact that x is greater than or equal to 0, y is greater than or equal to 0, I'm going to be in my first quadrant. Next, I also know that my y-intercepts are at 4 and 7. So that gives me an idea of where I want to set my window. So let's go to our window key, and I'm going to come down to my x-min. Now I know it's going to be in the first quadrant, but I'm going to want to find some intersection points on my x-axis and my y-axis, so I want them to be up high enough so that I'll be able to see them on my window. So let's make those at -5. we'll come down to our 10, to our x max, and I'm going to set it at about 10. And my scale there can be 1. The y, very similarly, I'm going to say -5. Again, I want to move it to the center portion of, not the center of the screen, but off so that I can see my axes, because I'm probably going to find some intersection points there. My y max, of course, my y-intercepts being 7 and 4, I'm just going to see above them. I'm going to go to 10, and I'm going to let my scale be 1. I'm not going to change my shade resolution. I'm going to leave that at 3. Now when I go ahead and hit my graph, it's going to graph this system of linear inequalities. And it kind of looks like a big mess when we're finished. And we can kind of see that the heaviest here is this darkest piece. However, I'm going to want to find intersection points and so forth so that I am allowed to minimize. So I'm going to use shades. So again, to access shades, I'm going to do alpha, y equals, because that's below shades. My original shade is this, and really the original shade is the union, being everything. I want the intersection. I want where they all overlap. So I'm going to choose number 1. It's going to regraph, and this time you'll see that it's only going to graph the intersection. It eliminates as it goes, and it's kind of cool how it does that. So let it finish graphing. So now I have my feasible region graphed, and I can take a look at that feasible region. However, to solve this problem, I need to find intersection points. And the intersection points are only the corner points of the feasible region. So I want to find this corner point, and this corner point. Now my calculator is not artificial intelligence yet, and it's going to give us all the intersection points. It's going to give us this point, this point, this point, and who knows what else point. But we don't want those that are circled in blue. We only want the corner points that are the corner points of my feasible region. And the way that my calculator is going to let me find them, make sure my smart turn is off, I'm going to use my point trace function, and that's over top of zoom. So I'm going to go alpha and zoom, and automatically begins at an intersection point. Well, we just kind of got lucked out, and it gave us an intersection point that we do absolutely want. 3 1/3, 2 1/3. So I know one of my intersection points is 3 1/3, 2 1/3. To access the rest, I'm going to start moving to the right using my right cursor. It's telling me up in the top left-hand corner that I'm on the intersection of y1 and y2. When I cursor to the right, my cursor is going to be following, and I can keep cursoring, following along all the intersection points of y1. So I was here, cursor once, it gives me down here to an intersection point, which I don't want because that's not an intersection point. When I click again, it then goes back to y1. Now it's giving me the intersection of y1, x1, and I do want that point, 0, 7. Well, I've exhausted all of those points, and really, I want to get to this intersection point. Well, this line happens to be y2. So I need to use my down cursor key, and it tells me now I'm at y2, y1. And if I start going to the right, I'm going to get that point. But you can see that it's now going to travel along y2 and give me every intersection point along y2. The one I want, though, is this one, which is 8, 0. Of course, now to complete the problem, you've learned in your classes that I would plug in each point and evaluate the minimize or objective function for 0, 7. I believe this point was 3 1/3, 2 1/3, and my last point here, 8, 0, and to find out which is going to be the minimum value.